Cool. So that's how you work out your estimated time of arrival. And if you're looking on the map and you are putting your fixes in and your time, and you think, right, I've got 20 miles left to go, you look around the edge for 20 miles, ding, you're doing 4.5 minutes. Okay, welcome back. How to work out your estimated time of arrival. You can't do it in your head, well, unless you're really good at maths, which I'm not. So what people normally do is they fly along in an aeroplane, a given aeroplane, say Cessna 172, for example, 100 knots. It'll do about 110, I think, flat out in a straight line. Not much more than that. Depending on your aeroplane, obviously, and how fast you're going. We use a dead reckoning computer. Okay, this is a dead reckoning computer. They're all available in plastic. This is an ex-military one, NATO one, which I bought from a surplus stores. But you can buy plastic ones, and they come in different speed ranges, as I mentioned earlier. Now, the important part of it is on the back. This is the computer dead reckoning. It's a slide rule, a circular rotating slide rule. So on the outside is our speed, okay, and on the inside is our time. So we simply dial in the time and the speed, and we can read off all the way around what our estimated time of arrival is going to be. For example, at the top here, I need my glasses, it says 10 miles on the top there. So 10 also equates to speed, 100 knots. So if I put the black arrow on 100 on 10 miles, that means 100 knots. That then, now you just read off the outside. So in 10 minutes I'll do 16.5 miles, something like that. In 30 minutes, follow it round to 30 minutes, which is there, 50 miles. Obviously 50 miles in half an hour, 100 miles an hour. Boom, there's not rocket science, is it? So if we're in a Hawker hurricane, which is going a lot faster than 100 knots, let's say it does 300 knots, we go round to 30. See 30 miles on the top there? So we'll whiz it round to the 30. We might not go that fast, but if we did, for example, half an hour, which is 30 minutes, 150. Okay, so you know, doing 300 miles an hour, you're going to cover 300 miles in an hour, so you're going to cover 150 in half an hour. So that proves that this thing works. Okay, but we're probably not going to go fast as 300 knots, are we, in a hurricane? Let's put it down to 250 there. So and we did a 20-minute flight. How far would we get in 20 minutes? We go around the outside, looking for 20 minutes, and it says 83 miles. Okay, well, this is a navigation computer. This is standard sort of PPL thing that you get when you're doing a PPL license, and on this you can work out your wind drift from your heading and your magnetic variation, things like that. And it has a speed card in it. Okay, this particular speed card goes up to 200 knots. The top there, 200 knots, which is great for your PPL and your single engine, piston engine, Cessna 172, PA28. Even if you get a twin rating, you go in a Piper Aztec or a Piper Scenic or something like that, where your speed range is up to about 150-ish, 60, somewhere around there. So you can still go up to 160, but you can see the card is starting to run out at that point. But if you're going to fly something fast, or faster than 200 knots, then you need to change that card and throw that one away. Okay, and put a faster one in there, because it still works. You can still work out your wind drift and your magnetic variation and your new course headings. But more importantly, on the back, this is really cool, because this is a slide rule. It's a rotating slide rule. It does several things, and it tells you how fast you're going. Now, normally with a Cessna 172, I'd be cruising about 100 miles an hour, and that would tell me in 7 minutes how far I'd go, or in half an hour, 30 minutes. But we're flying a Hawker Hurricane today, so how far can we go in 20 minutes? Well, we just simply turn that dial to the big arrow point there to 30 at the top there. 30. Boom, we line that up. So straight away, it'll tell us how far we're going to go in so many minutes. Yeah, so obviously it says 30 at the top there. I know this is reversed because I'm using the camera on the phone. It's reversed, so it's a bit confusing because it goes clockwise, not anti-clockwise. Okay, so yeah, put 30 at the top there. That equates to 300 miles an hour, and then the time scale is around the outside. So down here we've got 20 minutes down there, and it says 10 miles on the top, so that would be 100 miles. It's a little bit confusing, but it's actually quite straightforward when you get your head around it. You know, if you work that out, 20 minutes, so that way up, 10 miles, that means 100 miles in 20 minutes. So we can go 100 miles in 20 minutes. Dead simple. You don't even have to work it out in your head. You just turn the dial and read it off around the side, and it just goes up and up and up. You just add a naught or take a naught away or whatever. That's it, basically. Basically, it's really, really cool, easy to use instrument. It's not complicated. It looks complicated when you first see it, but it's not. As you see, it's got degrees all the way around, and we put the card back in. Put it in the right way around, G. Is that way? That way? Yeah, from the bottom. There we go. So what we would do, when we're flying along, we would set that point there on the speed that we're going to be doing, which let's just say 100 knots, such as that. And then our wind, what's our wind doing? Our wind's coming this way, so we'll put so many degrees in, and we'll have drawn our X, don't forget, as well, on there. And it just calculates how many degrees off to the left or the right you need to steer in order to maintain, because you've got magnetic variation you've got to put in there as well. Okay. So it's a really useful tool, and you will find that when you pass your pilot's license, you'll never ever use it again.